with no further ado, please start with your talk, Ned.
Okay, thanks, Anna. Yeah, so I'm going to ask and try to answer two questions. Can large language models have first intelligence, by which I mean thought, understanding, reason, and the like, and two, consciousness? I'm going to start with consciousness. I might not get to intelligence because I haven't timed this, and I do want to leave time for questions. So I just want to start with the observation that the backpropagation that these models use is a very old idea. So it was developed in the 1980s, crystallized in this famous paper by Rumelhard, Hinton, and Williams. That's from 1986. And there was another important paper of backprop used to play backgammon. And then in 1989, Francis Crick published a paper in Nature called "The Recent Excitement About Neural Networks," in which he complained that they weren't really neural. So the idea, as far as I know, is still the core of all LLMs, both in the transformer training and in the reinforcement training. I might be out of date about something, but at least as of a year ago or so, that was thought to be the case from what I know. So what's changed isn't some basic breakthrough, although the attention head architecture is a little tiny bit of a breakthrough. And of course, Yann LeCun's convolutional neural networks was something of a breakthrough, but that is not used in the transformer architecture. I'm going to start with theories of consciousness. I think there are four basic theories: the biological theory, the global workspace theory, higher order theory, and the integrated information theory. These are the scientific theories. So starting with the global workspace theory, I probably most people know the basic ideas of it. So the idea is that this outer ring is meant to be the periphery of the body, and these processors and links between processors. The idea of the global workspace theory is that the peripheral processors, some of them are activated, some are not activated, or activated less, and then there's a competition among them. And only one or two can trigger what they call ignition, in which there is a reverberating neural coalition involving both the peripheral processors and the central processors. This is a key point. Competition yields what they call ignition. And so, of course, feedback is just as important in these networks as feed forward. And as many people have noted, the large language models are mainly feed forward systems with a little bit of feedback. So more speculatively, it sounds to me, I don't have a proof of this or anything, but that this architecture of competition leading to ignition is really foreign to LLMs. I mean, it's obviously not foreign to AI or neural networks. You could imagine a neural network made to do this, but they're not the kind that have been successful. So I think the kind that have been successful do not look as if they can realize a global workspace, broadcasting the global workspace. Still, it should be said that you don't need a meat system for broadcasting the global workspace. It's definitely a very multiply realizable kind of architecture. So if global workspace activation is the core of consciousness, it doesn't look like current systems are the right way to go, although you don't need, nonetheless, you don't need meat. All right, moving to the higher order thought point of view. I'm sure everybody is fully aware of this. The idea is that the experience of seeing a red thing only becomes conscious when you have a thought about that experience. And what makes the experience conscious is that it is accompanied by or a thought is involved, a thought about it is involved. Then there's also the higher order pointer view of Hakwan Lao, in which what's higher order is just a pointer to the state. Now, thoughts have been claimed sometimes, notably by John Searle, to require consciousness. His view seemed to be that there was indeterminacy in the content of a thought, and only consciousness could get rid of that indeterminacy. But putting that kind of view aside, it looks like thoughts do not require meat, even if consciousness requires meat. And certainly the pointer view doesn't require meat. So it looks like an AI, some kind of AI system might be able to satisfy consciousness with the higher, at least some versions of the higher order thought view. Now, the integrated information view says that a system is conscious only to the extent that it's appropriately complex with many different possible states, and those states have to be integrated with one another. As many people have noted, the feed-forward systems are not conscious according to integrated information theory. You need, integration among the different components. Still, this is a highly variable, a multiple realizable system, and certainly doesn't seem on the face of it to require any meat. But the biological view, which I prefer, may require meat. So the model from Crick and Koch from the 90s is the SMART kind of idea, a model of what consciousness is based on. Water is H2O, or light is electromagnetic radiation. And importantly, this view is usually taken to be talking about a necessary feature of one particular sufficient condition, allowing that there might be other sufficient conditions. Now, why not just have a sufficient condition? Well, here's a whole brain. That's a sufficient condition for consciousness, and not a very interesting one. And then the idea has been, the NCC paradigm has been to find a necessary part of such a sufficient condition. I think the idea, though, here that seems to come up is that if we can find a necessary part of our sufficient condition, we might want to hypothesize that it's a necessary condition all by itself, not just a necessary part of our local sufficient condition, since we're the only creatures that we know to have consciousness. And the thought arises that there might be some biological property of our information processing that is such a necessary feature. Like, for example, electrical signals transformed into chemical signals, transformed back into electrical signals. So, as everybody knows, we have neurotransmitters flowing between cells. And then gates open, sodium flows, an electrical signal flows down the axon, and then neurotransmitters are released from the ends of the dendrites, again, starting the whole thing over again. So that's chemical change to electrical, change to chemical, and just one candidate for a necessary part of a sufficient condition. So note here that the argument that I'm suggesting is not the argument of the form all known cases of consciousness have F, so F is a plausible candidate for a necessary condition. Being made out of carbon would be a poor candidate for a necessary condition, because we know that mere composition need not be fundamental to how a process works. And many features of the way our brains operate would be poor candidates. A different kind of problem comes from a feature like being alive. So that would be useless in a different way because there are living things that are not plausible candidates for consciousness. So what we want is, and what we should be searching for this project, is find an F where all known cases of consciousness have F, where F is fundamental to our mental processing and not part of the operation of things that are poor candidates for mentality. And along these lines, we might say every strong candidate for a phenomenally conscious being has electrochemical processing that's fundamental to its mentality. Further, the strongest candidates among life forms for not being phenomenally conscious have no neurons. So that again gives a further boost to neuronal processing. But there's a problem, which is, whoa, hydras have neurons. And you can, of course, have neurons in a dish. And they can even be used to make these organoids, which have some properties of brains. But careful, if you do a little bit too much, you might get into something that's thought to be a person. This is an article that came out recently in a law journal about the possible legal personhood of human brain organoids. So to conclude on this, we should look for something about neural complexes. We don't know what will, no one has a really good hypothesis as to what such a biological necessary condition might be, but it is a reasonable object, something to be searching for. So the thought here is, if some biological theory is right, it may be that only a meat machine can be conscious. Now, of course, there's an obvious objection, which is neuroscience and biology more generally are computational, and you don't need meat to compute. So my response to this is a computational implementation of a rainstorm is not wet. Similarly, a computational implementation of a neural process might not replicate the conscious properties of that process. So at least there is a possibility. I mean, maybe the computational properties are what's important, but there's at least a possibility that that some other non-computational properties, something to do with how the computation is done, may be what's important. To the question, can an AI be conscious? So if consciousness is fundamentally biological, maybe not, maybe yes. If it's the computations, yes. If it's something else about the way the computations are done, maybe no. If consciousness is global broadcasting, maybe so, but probably not LLMs. It would take some other kind of architecture. If consciousness is higher order, maybe so. There's a couple of open issues. Okay, moving on to intelligence. In an article recently, Jan LeCun and Jacob Browning said, a system trained on language alone will never approximate human intelligence, even if trained from now until the heat death of the universe. So there they're talking about intelligence. They go on to say this is just the wrong kind of knowledge for developing awareness or being a person. That sounds a lot more like consciousness. So we just talked about consciousness, and let's move to talking about intelligence. So why do they think a system trained on language alone will never approximate human intelligence? By the way, Jan, in case you don't know, is the chief of AI for Facebook. So it's not like there's no authority there. Well, one reason that sounds a lot like some of the things that they say, I mean, some of the things they say sound a little bit like Searle's Chinese room argument, but so many of them sound a bit like what's the point of view in this Bender and Kohler paper, which introduces the octopus test. And so the idea of the octopus test, if you haven't heard about this, is you have two people on desert islands communicating by an undersea cable. An octopus is listening in on the table, and the question they raise is, could the octopus take the place of one of the people and say take the place of A and then communicate with B? And would the obviously octopus is meant to be the AI, and then the question they raise is, would the octopus be able to simulate A? And second, even if it could, would the octopus's simulations have any meaning? So now you can distinguish between the octopus having access only to language, the inputs and outputs maybe being pixel arrays, and the inputs and outputs being sensory motor. It's clear that they allow both of these. Pixel arrays are legit, and we can distinguish between two different conclusions. So one is the octopus won't be able to successfully imitate A, given the linguistic inputs only. And second, even if it does, the contributions won't have meaning, and the octopus's mental states won't have the relevant intentionality. So they seem to mean both. This in this paper and some later work by Bender, she seems to mean both. Now I have to say that this paper was originally written in the light of GPT-2, and it really does look like later language models make it look like this isn't that plausible. But of course, there are problems with, many people have identified various, kinds of problems in even the most sophisticated of these large language models. So maybe Bender would continue. I mean, she certainly has, if you follow her on Twitter, she's very skeptical about the mental abilities of large language models. So maybe she doesn't think that even though they were based on GPT-2, that even GPT-4 is really doing a better job in principle. I think the way to see what's wrong with this is to think about a view called functional role or conceptual role semantics. So this is an idea first put forward by Wittgenstein and Sellers, at least in modern times, and taken up in the 70s by Hartree-Field and Gil Harman. These are the philosophers, but also in psychology, there's another doctrine called procedural semantics, taken up by Johnson, Laird, and Miller, and then in AI by Bill Woods. So this is an old idea, and the main idea here is that meaning and intentionality can be understood in terms of the functional role of a representation, a syndrome of causes and effects, which includes production by inputs, interaction with other internal representations, and contribution to the production of outputs. I emphasize in yellow here the interaction with other other internal representations, because that's what makes this non-behavioristic. It is the role of and so Wittgenstein might not have been very happy with this, but the idea here is that it's the role of a representation, the causal role, including the internal causal role. Importantly, not every causal interaction is part of the conceptual role. These theorists often talk about conceptual role. So, for example, you have representations in your head that interact very weakly with electrical currents and wires in your walls, but we don't count that. Okay, now importantly, we can divide these functional roles into what I long ago called short arm roles inside the head. So, for example, if you think that something is a dog, then you might conclude from that that it barks or that it's an animal. So these are inferential roles inside the head, but there are also roles in a wider sense that connect the words in your head with things in the world. And sometimes this is sometimes called a two-factor semantics. The idea is that there's a factor inside your head and a factor that connecting your words to the world, so-called referential factor. And the idea is that the roles include sensory representations and motor instructions, even the short arm roles. Now, a key point here is that the referential factor includes borrowed reference, and that's enough to give the octopus some intentionality. And this borrowed reference is often ignored even by AI people who talk about the functional role point of view. So here's Steve Piantadosi and Felix Hill. They say, already we have stamps that only have barcodes and stamps that you can draw yourself. You know the term postage stamp, but there's no way that you could have considered all the possible reference yet, so reference cannot be what determines the concept. They say very roughly, people call something a postage stamp. If you pay for it, then attach it to a letter in order to have the letter be delivered. In this view, the meaning of the word is intrinsically intertwined with other concepts like payment, letter, and delivery. So that's only the internal role. Now, I happen to think there's a lot of disagreement among philosophers about this, but I happen to think that internal role grounds narrow content. But in any case, one approach to the octopus problem is just borrowed reference. So the octopus has intentionality because of borrowed reference or other features of the referential factor. So anyway, the first response to the octopus is borrowed reference. A second response is narrow content. So a lot of us are happy to think of a brain in a vat, or to use Adam Poutz's version of brain in a void, a swamp man brain in a vat, as having narrow content. And so that's a different approach. They say we start by defining two key terms. We take form to be any observable realization of language, marks on a page, pixels or bytes in a digital representation of text, or movements of the articulators. We take meaning to be the relation between the form and something external to language. But we can take the meanings not to be like, have meanings like that, but to have narrow meanings. So I think those 2 points are enough to respond to Bender and Kohler, but still, there is room for doubt that current large language models really do have the right conceptual roles. So here are a whole lot of flaws that people have alleged. One is that the LLM weights, the weights of the system, do not encode a model of the world, or do they have an explicit memory, as we are supposed to have. They don't even model, so as everybody knows, the way these systems work is there's a window of text that moves, predicts the next word, and then moves to include that word in predicting the next word. But they don't even model the current situation in their window of text. As Gary Marcus has often claimed, they don't have variable binding or recursion, or as Stan DeHaan has claimed, they don't have hierarchical linguistic representations. Now, I don't have time to talk about very many of these, but I'll just mention the model of the world. So here's a question that I asked Bing. I might not have gotten GPT-4 when I asked Bing, but I've asked a number of language models this question, or questions like this. So here's the question. From my location, if I walk 1 mile north, 1 mile west, and then 1 mile south, I end up at the same place. Where is my location? So these systems, I mean, I tried GPT-3 on this, and it got it wrong, and this system gets it wrong too. It says the location is the North Pole. Actually, the location is the South Pole. And its reasoning is poor, and if you ask further questions, you get other bad reasoning. So this is one of many examples where it looks like there's a failure to have a model of the world encoded in the system's weights. So here is one about the current situation. I saw this in a post, and the person, but Fred and Ethel are next to each other, and no one else is there. The person next to Fred likes coffee, so we might think this. Fred and Ethel, the person next to Fred likes coffee. That's Ethel who likes coffee. The person next to Ethel likes tea. Which one likes tea and which one likes coffee? So I asked this Bing a chatbot this question, and I got the person next to Fred likes coffee and the person next to Ethel likes tea. Therefore, Fred likes coffee and Ethel likes tea. Is there anything else I can help you with today? So I said, are you sure? Check your reasoning. I apologize for the confusion. I made an error in my previous response. The person next to Fred likes tea. Woo. The person next to Ethel likes coffee. Therefore, Fred likes tea and Ethel likes coffee. Thank you for bringing this to my attention. So Raphael Millier did it with GPT. I thought I was getting GPT-4, but I may not have. He gives us the same question to GPT-4 and got a correct answer. But the guy who originally got this post from tried a lot of different language models and found, even when they got the right answer, if you asked them a further question, they showed lack of understanding of it. So I'm really not convinced that that these systems either model the world very well or model the current situation. So one item of fallacious reasoning, I think, that is easy to be involved, that my colleague Dave Chalmers has nicely refuted, is this. The fallacious reasoning is LLMs just complete patterns, so they don't do these things. And as Dave points out, you might as well say organisms like us just maximize fitness. So we don't think, reason, learn, build cities, invent theories, etc. So the fallacy there is, yes, LLMs just complete patterns, but maybe in order to complete the patterns, they have to do things like variable binding recursion, hierarchical linguistic representations. So we cannot conclude just from this that they don't do these things, although I think many people have pointed out that a lot of the problems that come up do seem to involve problems with this. Stan DeHaan used GPT-2 to argue that against the hierarchical linguistic representations. And one of the things he did was long-range subject-verb agreement, and found that GPT-2 had a lot of difficulties with that. Now, of course, these other models are much more elaborate and may have developed some kind of hierarchical representations. So there's a lot of work now, seemingly arguing for at least some elements of hierarchical linguistic representations, but I think the jury is still out. Now, let's see, in the chat, Dave has posted GPT-4's answer to the South Pole. From my location, if I walk 1 mile north, 1 mile west, and 1 mile south, I end up in the same place. Where am I? So here's what GPT-4 says. The most famous answer to this type of question is the North Pole. So at least Dave got a wrong answer from GPT-4, and then it continues on. Well, okay, I don't have time to read this carefully, but it looks like it gets it all wrong. Yeah, so that's, I didn't realize how quickly this would go. So that's all the slides I have. So we can open it to questions.